Hey, how's it going? So, maybe I wanted to begin by like talking about what we're both working on.
That works.
So why don't I start with myself? Um, so I'm working on, I guess, four things right now, and really the way to understand it is I kind of in January I left my flat, returned my car that I was renting. I went traveling for a bit. I went to Mexico. I had a client in California, so it was better time-wise because I'm in Europe normally. And the contract kind of ended, and I was in Tulum, which was super expensive. So I was like, I don't really wanna be here. I had like the last freaking $2,000, and I said, fuck it, and I just went to India because I really like it there, and it's really cheap, and I know a place there that like a lot of international cool people. Spent everything there and got back. So now I'm staying with my parents, which is actually really, really nice. And also, the obviously much lower cost. So I can sort of have that luxury to do some things that like don't have immediate payoff. And so what I'm working on right now is essentially four things. So so yeah, we have this tool called E0x, which is basically like tooling infrastructure. We have everything from Solidity version management to AST parsing, stuff like that. And what I'm trying to do, I think, is going to be one of the coolest features, at least from a static analysis perspective. So what I'm trying to do is create this like dashboard thingy. So imagine you type in woke dash and it opens a HTML page with everything from the infrastructure graph, the inheritance graph to like the call graph, and everything is interactive and stuff like that. So that's what I really want to do. I'm considering updating the yellow paper. Um, I don't know if I want to apply for a grant for this, but I think I will to some degree. I want to rewrite it in ASCII doc. Um, I want it to be web first. I want to integrate all the EIPs and a lot of other changes, right? So yeah, maybe let me take a break there. And what are you working on?
Yeah, so obviously very interested in sort of static analysis stuff, first of all, and I do think that that's a really valuable area to focus on within sort of assurance tools is better visualization and better ability to consume the information provided by those tools. Uh, I'm working on a few different things. Like always, can't just work on one thing, right? So I am working on the Athena proof assistant, uh, which is a natural deduction proof language, similar to Coq or Isabelle or Lean, but uses a very different underlying theory. Anyway, I'm working on getting a more robust documentation up and sort of starting to use it for some projects in the blockchain space to sort of get the community created and grow the community a little bit in the blockchain specific industry. The other thing been working on for a while, just have to find the time to sort of implement the final component is symbolic EVM in Rust. Uh, a while ago, I started it and fell into the whole over engineering trap and ended up trying to create just more of a generic framework for symbolic execution, which essentially you would pass it a strongly typed definition of an instruction set, and it would generate a symbolically executable machine for that instruction set. That project still exists, but it's too complicated. So I sort of put it on hold to just get an actual EVM, symbolic EVM working.
Would that be
And
the same goals as, for example, the K framework?
Not really, because K framework, is very generic. Uh, K framework is basically a term rewriting engine, um, but they use a little bit more sophisticated type of logic than rewriting logic called matching logic, where you can do like partial rewrites of uh, basically structured formula. Um, and then they use that. So the interesting thing about rewriting logic and whatnot is that uh, it's very good for creating executable formal specifications, because this sort of formal relation called a rewrite can be used for logical proofs. It can also be used to represent execution or steps of a computation. So that's how K formally models things and allows you to formally specify things. And they use the KVM, which is probably, much more. KVM is unique because they do discharge to sort of SMT solvers certain queries, like all symbolic execution tools basically do that. But they also perform some things, uh, some types of analyses using the K framework and its particular sort of capabilities, and for example, checking which states are reachable. So K framework would be more analogous to Athena in terms of its how general it is. Uh, and I will at some point build a library in Athena for that makes it easier to specify execution models and languages. And I will likely build an EVM, a formal EVM in Athena as well, after I finish the symbolic EVM in Rust, which is a bit more short-term and practical. So yeah, so the symbolic EVM, Athena, and then yeah, creating a new school, as you know, because both of us come from sort of security space as well, and very privy to how many things how many vulnerabilities make it into production. Like $3.8 billion lost last year due to faults in blockchain code, which is a crazy amount, not really acceptable in any other industry. So how do we fix that? I do think that part of it is education problem. So basically working on creating the really the most rigorous and in-depth education program for people who want to be blockchain engineers. So we will focus on things like the fundamentals of computation and mathematics, focus on financial engineering, focus on consensus and distributed system design, incentive design and game theory, and sort of more the and then more the topics that are typically taught in, say, a uh, boot camp or something, in like smart contract development, auditing, uh, and security engineering, and things like that. So next year in February, we plan to make it a full degree program. We are engaged with the creditors, but we're going to launch it initially as a little bit more restricted program that
Yeah.
people who complete it will be able to apply those credits when the full degree program launches as well. So yeah, that's I think the a not very short summary of the stuff I'm working on.
Yeah, that sounds great. What everybody's interested in, what's going to be the pricing?
Yeah. So the pricing model is a bit different, especially when the full degree program launches. It'll be very different from what people are used to with, say, a university or a boot camp as well, because we don't time box anything. The reason being that we use a mastery-based approach to teaching. Uh, so instead of, say, measuring progress by number of semesters, where you could, for example, get a C minus or something and still make it through that course with the bare minimum level of competence, we require the utmost competence, right? Because we're building systems that people are throwing hundreds of millions of dollars at. We need to be good at it, right? And so we use mastery-based approach where in order to move on, you have to prove mastery. So we have very strong a really strong group of people ready to sort of design and build and grade assessments. And because of that, the only way to charge for mastery based really is subscription based because it's self-paced. If you're an expert in multiple domains already, you should breeze through those parts. If you're not, it should take you a while. And we are thinking that we're going to do $500 a month for the full degree program, which is in the American market at least is significantly less than even the most affordable universities. Obviously, in some other places, people are used to free college and things like that, but still willing to pay for very specialized training. For example, people who are used to free college still pay 50 grand for a boot camp. So we think it's a pretty good price for what you're getting, especially when you graduate. You can choose to just go off on your own. You can choose to enter the incubation program. We'll have sort of legal support, product support, marketing support, team formation support, or enter into our sort of network of preferred employers where they've sort of committed to, because they understand the quality of the graduates, because of the rigor of the degree program, they sort of want first dibs on graduates. And so it's a nice little matching market there for employers and potential employees.
That sounds great. Maybe I'm gonna give a short presentation about Solvio. So,
Yeah, that's cool.
yeah, so I want to tell people about this startup that I worked on. So, what was the background? The background was like, where was I intellectually coming from? I had dropped out of college and I had learned a lot of theory by myself, but obviously I never kind of had accreditation for that. And when you're early in your career, accreditation is important, right? And then the other side I was coming from, I had also started a boot camp, a math camp company, physical, and a lot of people were saying that they would prefer that math camp or string of math camps to maybe a full-time high school. And so that sort of got me thinking, is it possible to design essentially a parallel education system that would sort of be 100%, online first, 100% sort of curiosity and freedom based. So you can pick these physical courses and travel to them maybe if you want to, or you can, for example, just study everything online, right? And so I saw it essentially as a problem that can be separated into subproblems. One of them is finding these resources, and resources can either be physical courses or they can be online resources. Now, finding resources is a little bit more complex than it may initially seem because you also have to give the student or the user the learning dependencies. So if a high school student looks up, he wants to study quantum physics or blockchains or some kind of especially multidisciplinary topics, they have to understand a lot of prerequisites. So that was sort of where I was coming from, and the names of the individual products changed as I was developing them. This is the most complete document, the most complete sort of as far as I ever got to writing all of my ideas down. And essentially in this white paper, I describe it as Content Hunt, which gives you the online materials, books, stuff like that with their learning dependencies. Problem Hunt is a little bit tangential, which maybe I'll talk about some other time. And then Course Hunt, which also enables you to find these physical courses. And so maybe two interesting points I want to point out. For Content Hunt, the idea there was that each of the learning resources would actually have learning dependencies that would go to a topic, right? So most people think of learning dependencies, for example, if you go to Reddit or something, they think of learning dependencies as an edge between topic and topic.
Hmm.
I thought of it as an edge, or sometimes even think of it as an edge between resource and resource. I thought of it as an edge between resource and topic, right?
Mm.
So there can be multiple resources on the same topic that have different prerequisites. This actually enables a lot of really cool things because now you can say, hey, I'm a mathematician. What's the best way to learn topic X given that I understand math? And somebody can come in and can say, I don't like math or I don't know, a lot of math. What's the best way to learn X without, having these math prerequisites? So that was sort of how I was modeling the process of learning. And maybe last thing I want to point out is learning is great, but at the end of the day, a lot of education, especially in fields like maybe economics or law or like some humanities fields, there's a lot of more so first of all, it's harder for employers to verify your level, right? In engineering domains, it's more easy, but in sort of humanities, it's harder. And so you need a way for accreditation. Accreditation is even more important there. And so I spent a lot of time, especially after this white paper, thinking about how do you accredit people for their education. In this particular white paper, I have a chapter on it right here where I write, I think all of the above are extremely good reasons why something like Content should exist. Nonetheless, the greatest value of this platform is that it also solves the problem of signaling. Say a student learns about the causes of the Great Depression, they would then produce and submit a resource on that topic, for example, an essay or video. Others that are learning about the topic will use that resource, and depending on the information they provide, such as how much they learned the depth of the presentation, we have a proxy for the author's student's understanding of the topic.
Mm.
The user's profile would have, so essentially, initially the idea was to either for students to create these works and then other people to like grade them sort of, or even like the process of submitting these like sort of structured reviews of various resources would be a way to grade the works. Now, the last thing I'll say is that obviously in 2018, I did not expect the rise of GPTs, and I think in the modern context, this doesn't make sense. And so actually, I think I'll keep it at that. So that was kind of a gentle introduction to Salvio. What are your thoughts on that?
Yeah, so the signaling aspect, I actually really do agree is important. That's an interesting way to approach it because it essentially reminds me of, well, first, at face value, it reminds me of more of like some sort of living skill tree, right? So it's like a better version of a resume or a credential because it's also self-attesting. So you don't need to say, for example, if I want to say that I know topic X, well, the evidence that I know topic X is completely intertwined with the claim that I know it. Whereas in normal certifications and things like that, you have to go verify from the issuer of the certificate if you actually want to see if someone has it. Second, it allows for more nuanced claims about someone's skill as well, and by uh, by consequence, more nuanced queries. Uh, for example, if I'm looking to hire a professional in, say, for example, multi-party computation or even zero-knowledge cryptography. Yeah, let's go with the zero-knowledge cryptography example. If I'm looking to hire a professional now, just saying to a recruiter, for example, that I want someone who's an expert in ZK tech, isn't sufficient actually, because usually, if a company is doing that, they already have specific commitments to specific sort of proof scheme, specific type of proof, and probably even have a protocol themselves. So what they really want is something more nuanced. They want someone who's an expert in ZK, but and who could either learn the stuff that they're actually using, or ideally they want someone who already knows all of the stuff that they're using. That's a lot more nuanced than saying I want someone who's an expert in zero knowledge cryptography.
Right, right.
Something like this allows you to query at that level of granularity, which I think is really interesting. Yeah.
Yeah. Maybe I'll also show off like what I actually ended up building in the end.
Mhm.
So let me just quickly go to GitHub. Um, Amos app was actually so the first app that I wanted to build was this search engine for learning resources, essentially. And yeah, this was really hard because I was running out of cash and I had a little bit of front end experience in the past, but not so much. And I'm pretty happy with what I ended up doing. Like, made a full-fledged, React app. Um, had to do like a server, had to deploy it. So this was sort of my software engineering bootcamp. Um, so I ended up deciding that at first the what I call the learning tree should, or I guess here I call it the topic graph, should be sort of centralized, fixed, and then later on you could think of a mechanism of like committing to the tree, right? Using some maybe shelling game mechanism and stuff like that. So I defined this .amos format. I don't know why I did that. It was it's basically just a JSON. Well, I think it's not. I think I think the reason I didn't want to use JSON was because I think I wanted cycles in there. I think that was the idea.
Oh, okay.
Um, let's see if I can find it. Topics all. Yeah, that might be the one, and I'll also show topics.
So you have to write your own parser and things as well.
Yeah, yeah.
Oh, that's so funny. Yeah.
Yeah, here it is. Here it is. So this is how I sort of wanted to structure the whole thing. Was you have academia, and inside you have hard sciences, and inside you have formal sciences. And what's a formal science? So mathematics and computer science. And yeah, then you just go down, and you have natural sciences, right? And you have earth sciences, and you have engineering and technology, and then maybe later on you get into some other forms of engineering, and maybe later on you get into like medicine and also social sciences.
Hmm.
Let's see if there's anything interesting here. Turns out there's a lot of subfields of sociology. Um, and yeah, sort of that was the idea. So yeah, to sort of second your like granular querying of user skills. Yeah, that was the idea, to have this like very granular topic graph, and then think of ways to edit it. But yeah, this EdTech thing is currently it's currently stale, at least the format that I was going to do it in. Maybe I'll just quickly finish off. So in terms of like the credentialing, I kind of think that in the age of GPTs, you can't really use the format where you submit resources. Maybe it could work like you have some kind of video, like video interviews, but even then I've seen people try to come up with like ways for GPT to help you in a video interview. So I think that the only way to do it at this point with like artificial intelligence is to do like physical sort of testing. So there are already institutions like obviously the International Baccalaureate and SATs and British Council that have these networks of like trusted physical locations around the world where you can take exams. So at some point I think that that is the only way to do it if you want to go this traditional way of giving credentials to students. Now, sometimes I see people say like, what is the whole point of exams, and even like why forbid people to use GPTs? And personally, I kind of think they're missing the point. I think only somebody who has not worked in education or has not thought a lot about education can say that, because at the end of the day, if you're tough on the training field, it'll be easy on the battlefield. And education is really about going deep into the topic, sometimes much, much deeper than what you end up actually doing in real life, right? Everybody knows that. Like when you're studying, for example, these days I'm doing a little bit of like quantitative finance, and there's a lot of math in the theory, like Black-Scholes, stuff like that. But then in practice, it's mostly about just, using Python libraries, or maybe
Hmm.
C if you want to write your own custom code, right? And in ZK, it's the same thing. You can go really deep into the theory of zero knowledge, but then in real life, maybe you're using a language like Cairo, right? So there is this discrepancy, and it's a good thing, right? It's necessary that in education you go much deeper than maybe you do later on in practice. So I do think some sort of examination makes a lot of sense. You can't just say, oh, education is useless. All that matters is like practice. No, I think there is a place for people to prepare for industry, and go much deeper in terms of the general concepts there. So yeah, that's my stance.
Yeah, I have some thoughts on that too. Uh, because I actually really like and appreciate exams that are graded. And when the goal isn't just to pass for the sake of passing, so that's why, for example, in the school that I'm creating, mastery based already aligns incentives a little bit where you have to actually be there for the learning as a motivation, because you can't just like surf by if you don't understand the material, right? So you have to care about understanding the material. And if you actually do care about understanding the material, assessments become really, really valuable. That's one of the things that there are two sort of properties of directed education with a teacher of some sort form that separates it from self-guided study, which is structure and feedback, right? Structure, if you don't know what you don't know, if you're new to a field, it's very difficult for you to evaluate which resources to choose, like what you were talking about, as well as the order in which to go through them and what to focus on, what rabbit holes to follow, which ones to ignore for now. That could be solved by curation services that are automated, like what you were talking about is sort of helps really, really powerful curation system. Um, then there's also the feedback component, which you need experts to provide feedback, because even when things are, for example, say you are tasked with doing some sort of programming based assignment, project based assessment, even if it passes all the tests, for example, there's a test suite. Maybe there's a test suite provided that in the primary task is make all these tests pass. There's still a lot that can be learned from receiving feedback from an expert in terms of how you factored your code. If you were to, in a follow-up sort of question-based part of the assessment, for example, an instructor might ask, so if you were to add this feature, this additional feature, how difficult would that be given the way you've architected your application? Oh, that would be difficult. You'd have to change a lot of things. How would you change your code that you've written right now to make it easier to update or add features in the future? Those kinds of things, right? And so assessments are a great way for people to determine if they actually understand as much as they think they understand. Because
Yeah, for
what's
sure.
worse? Yeah, what's worse? Lacking understanding now and being aware of it, or going in to a professional setting really confident that you know everything, and then it turns out that you barely have a grasp on what you thought you knew, right? Assessments are amazing
100% agree.
for that reason. Yeah.
So let's talk about your startup. I'm really interested. So full disclaimer, I might also be teaching there, right? When are you planning to launch it, and how can people sign up?
Mm-hmm. We're gonna actually open applications up in the next few weeks, uh, and they can then apply on the website, and then we will start the blockchain engineering specific course, training program or curriculum in September. So in that program, we'll cover some things. So we'll cover actually some foundational mathematics as well, for especially because we will be teaching cryptography, uh, and it will cover the mathematics required as well for finance and financial engineering. But it will not be the full program where you are also learning all of the theoretical basis of classical and decentralized consensus algorithms. We won't have all the remedial elementary courses on, say, peer-to-peer networking and stuff. But we'll basically have, yeah, foundations section for the mathematics needed for cryptography and finance and things like that. Have a blockchain section where you dive deep into how blockchain networks, protocols, layer ones are constructed themselves, um, and then and how they work. So we'll use a few different chains as very deep case studies there. And then we will have smart contracts development, sort of, I guess, section of the curriculum where people will learn how to write smart contracts, how to use the tooling that's available, best practices, common design patterns, which then sort of evolves into breaking smart contracts as well. So people will go through a slew of sort of capture the flag based challenges that are graded with feedback. They'll have to produce write-ups and things like that that are graded, learn sort of all the professional auditing side of things. And then they will learn the sort of fundamentals of formal verification. So not just they'll get an exposure to the tools that exist, how to use those tools, as well as the foundations of how they work. For example, people will be building as one of the projects a simple but solid SMT solver from scratch. So, and they will understand how those sort of automated reasoning techniques work. And then we'll go into and then it concludes, sorry, it doesn't conclude. There are two more sections. There's the finance. So they'll learn the sort of fundamentals of finance in general and financial engineering. You mentioned the Black-Scholes model, for example, right? So stuff that you've been talking about as well. And then apply it to the DeFi space, which sort of, yeah, we'll talk about the unique differences between when you go into DeFi versus regular finance. For example, some assumptions in traditional financial technology. An important assumption is how quickly things can be updated, for example, very high frequency. Whereas in blockchain, there are a lot of bottlenecks. It's really difficult to sort of support certain use cases because of the fact that just consensus takes a little while. And from there, we move into cryptography. So talk about the fundamentals of cryptography, mathematics for it, all the algebra necessary, number theory. Some of that includes actually proving some important axioms using a theorem prover that was learned in the formal verification section. And then they will also have a significant deep dive into the internals of Starks right now specifically. We'll cover Snarks as well, but we're covering Starks in much more depth for this first version of the curriculum at least.
So it sounds like a really multidisciplinary course between mathematics,
I
cryptography,
guess it probably
traditional
take 4 or
computer
5 months for
science,
people to get through.
traditional finance. Okay. Okay, interesting. Yeah, that's going to be a lot to cover. Feel free to get inspired also by two institutions that I think have really great materials. One of them is Oxford Maths courses. Let's see if I can find it to give you an example. So this is something that I've been doing recently, is I've been sort of going back and checking out some of these courses. And, I may have dropped out of Oxford, but I fully vouch for that institution, extremely strong, content. So, yeah, I've been mainly focused on prelims and part A. So induction, I think, I don't know what that is. Prelims is year one. in Oxford, and I think Cambridge as well. Part A is the second year of the course, third year, and fourth year. It's split into trimesters, and yeah, Michaelmas is until Christmas, Hilary is until Easter, and Trinity is until summer. So yeah, whenever I want to catch up on some math, there's some really, really strong content over here. So in particular, recently, and I'll go over that in a second, I've been looking at calculus again. So when Oxford says something is introductory, it for the rest of the internet that means advanced. So don't get don't take these words literally. So I've been looking at calculus, probability, and statistics. Computational math just seems like MATLAB, which I'm not so interested in, so I didn't really look at that. I think statistics might be in Trinity. Yeah, statistics and data analysis, and then there's another course in the second year on statistics and probability here, and then there's another one statistics. So these are the ones that are printed out the day before yesterday, and then I'm going through right now. And then the other institution that I think also has pretty good content is the Cambridge Computer Science Laboratory, I think it's called, which is their laboratory, which is their CS department. And this is where I go for CS material. I'm not sure I can find it right now because it's been a while since I took any content from there. So I'm not going to try to find it now, but you could probably find it. Maybe I can try like courses, I think. So let me just do this one query. Yeah, okay, I found it. So let me click on this link. Yeah, so here you can decide how much of CS you want. So you can just pick I guess the maximum one. And you get a lot of good content here as well. So I took some of these courses too. So both of these that I'm showing right now are not video. They're very, very good PDF. So maybe I'll give just a quick example. So for example, the probability one in first year. So you click on it, right? And then you click lecture notes. And what I don't like usually is I don't like reading slides.
Mm-hmm.
But fortunately in the maths department at Oxford, all of the lecture notes are in terms of LaTeX, and so they're literally like textbooks. They're like slightly short versions of textbooks. So it's very, very, very strong material that I 100% recommend. Cool. Yeah, let's quickly wrap it up. I'll maybe start off by finishing what I'm working on, and so I kind of want to extend fuzzing in the Ethereum ecosystem, and I think the future, to some degree, is going more and more into economic security,
Mm-hmm.
as well as traditional sort of code security. So that's why I've been looking into calculus, probability, statistics as like what I call the fundamentals, maybe, even though they're really kind of applied math. And then in terms of applied, I've been just looking at just been reading some books like finance in Python and stuff like that. And then I've also been kind of catching up on a lot of blockchain papers. I plan to do an awesome blockchain papers GitHub repo. I have a really cool methodology for finding the best blockchain papers on any topic. But we don't have time to go through that. And then I also am teaching the next 3 cohorts at rareskills.io. So if you guys are watching this video and you want to sort of level up your skills in terms of the EVM, in terms of Solidity, and we're also going to go into DeFi, this is the place to be, right? So this is the place where I share all my knowledge right now. Yeah, and maybe one last thing I'll point out, I've for like approximately a year ago, I decided I want to try Vim, and it's been a really interesting journey. I knew from the start that I will be doing a woke plugin for Vim at some point, because we built this project called woke, and one of the features it has is this language server whose whole premise is that you write the server logic once and now you can run it in any editor. So I knew from the start that if I'm going to go serious into Vim, I might as well do a plugin at some point. So I kind of always, took it very seriously, my Vim journey, and because I knew that it would also, I would contribute professionally. So I went the long route. I ordered this Vim book that I really, really recommend. It's probably the only book that's worth reading on Vim, but I strongly recommend it. It's called, uh, I can't remember the name right now, but you guys can definitely find it. I will. Yeah, it's called Practical Vim. It's called Practical Vim. And I'm almost done with that. So really excited about my setup, and also maybe interested in sharing some of the things I learned. So this is how my setup kind of looks like right now, and I can maybe just give a quick sneak peek. So yeah, I got telescope going on, fuzzy finding for files. This is how the files look like. I can do things like I can open a symbols outline. Let's see if that's going to work, right? So I have all the symbols in the file, and in general, really happy with this. What about you? What editor are you using, and do you just prefer? I totally understand the idea of like I want my editor to always work. I don't want to spend time configuring, and for that purpose, VS Code is the best. I want to just bridge the gap, maybe with some content that I'm planning on producing between those type of people and this type of setup. So if I produce
Hmm.
content that makes it easier for people to get this type of setup with much, much less work than I had to do, that's going to be mission accomplished for me.
Yeah, yeah. So this is really cool. I've always been, anytime that I'm sort of on a somewhat extended break, I always go back to how can I make my development setup just cooler, more efficient. I don't like moving my hand to the trackpad or the mouse like most developers, right? So I prefer if everything could be keyboard. Um, yeah, so I was using Emacs for a while, uh, and I was using it because I was doing a lot of functional programming, and I was using Emacs and Athena because Emacs was sort of Athena had support in Emacs, but not in any other editor uh, originally. So that's where I was doing all my Athena work too, and I really, really liked it. Although we recently did release a VS Code plugin for Athena because we built language, we implemented a language server protocol for the Athena language, um, and then built a VS Code extension with it as well. And so now I actually did switch over to VS Code for Athena because it's it's much more robust in its ability to sort of in its error messages and its ability to explore the code and things like that. So, and a lot of people use it, right? Like it doesn't require many configurations or remembering many. I mean, you can remember a lot of different hotkeys and things like that, but you don't need to in order to use it.
Just out of
Uh,
curiosity, did you try the LSP in Emacs?
I did not try it in
Not
Emacs
yet.
actually. No, not yet.
Yeah. Cool. Anyways, I have a hard stop at 5. So let's wrap it up now. Yeah, that was really enjoyable. Let's do a debrief later, but for me it was great, and I would definitely love to continue. So yeah, thanks so much for episode 0, and let's talk later. Cool.
Yeah, thanks,
Thanks,
man. This
man.
is fun.